and I this afternoon. We're going to be looking at multiplication using manipulatives, and this is the first time we're doing some online webinars. So thank you so much for bearing with us as we learn about that. You will notice in the chat, so Prisha's going to be monitoring the chat, and my name is Jackie Decker. I'm the secondary math consultant. I'm going to be leading the learning, and Prisha, our elementary math consultant, is going to be monitoring the chat and jumping in as needed. So you're going to notice right now in the chat, you do have a link to this slide deck. So if you want to have your own copy, you can either look at that now or after our presentation is done. So the learning goals for our session right now are here on the screen. We're going to really focus on understanding different models of multiplication, and we're going to be exploring concrete ways to explore those models so that can help our students develop a better understanding of multiplication and practice their skills using manipulatives and games. So we'll begin with a minds-on activity to help you empathize with your students and help us remember what it feels like to be learning something new. So I'm going to put up a number on the screen for 15 seconds, and I'm going to ask you to memorize as much of this number as you can. So if you're comfortable, we're going to ask you to type as much of that number as you remember into the chat. If you just want to hold on to it, maybe jot it down on a piece of paper or remember it. We're going to share those in just a moment. Prisha, are we seeing anything in the chat? You there,
sorry,
Prisha?
I had my mic off, sorry.
That's all right.
It's just coming up right now, sorry.
Okay.
We do have, Christy thought 25112347, and Jessica's got 2511. And then
Awesome. Okay.
And Elena has 2511234795.
Wow.
Let's
So
check it out.
I'm wondering if people want to just think about what kind of strategy they might have used to do that. And if you're comfortable sharing your strategy, throw that in the chat as well, please.
So Christy actually thought she tried to think of it as a phone number. So I'm wondering if, like, did you chunk it into by 3 then, Christy? Like, oh, yeah, and Alana thought about it in doubles. So 25, 11, 23, 47, 95.
Okay. So that's really interesting that that's what comes out, because we know when our students are trying to memorize things that they actually use a lot of those strategies too. They will break things into chunks. But if we can help them understand and see the real patterns in the numbers, that can actually help them understand more and remember it for longer, because there's meaning underneath. So if I told you that in this sequence, if we take that 2 and multiply it by 2 and add 1, we get 5. And we multiply that 5 by 2 and add 1, we get 11. It's a lot like the doubles that Alana saw, or the near doubles. Take the 11, double it, add 1, we get 23. And you could remember this forever now, and you could also actually extend it. And so we're going to really focus today not on memorizing a bunch of isolated facts, but actually developing those multiplication facts from memory, which we call automaticity, when that is situated in strategy and in understanding, then we can hold on to those facts for longer, because we do know that the basic facts are important. That's why we want to focus on them. They're useful in school, they're useful outside of school. We know that those estimations that we do in everyday life are really important to have those multiplication facts. And we know that kids do better in math if they have them. But it's the how we're going to focus on today, because if it is just rote memorization, students often forget those facts, and it takes up a lot of space in their brain, and it doesn't free up that space for other problem solving. So we're going to focus on a strategies-based approach instead, and we're going to show you how you might do that with students. So we're going to model multiplication in a number of ways to build those strategies. So I'm going to ask you to open a new tab on your computer and either go to this link, which Prisha will copy into the chat, or you can just Google Math Learning Center number pieces. Or if you've made a copy of these slides for yourself, you'll notice that the next slide has some base 10 materials that you can actually click and drag and move around. So I'm going to give you a couple of minutes to go and get that open, to play with those, get comfortable with how those materials work. And after we pause, we'll come back together and we'll get you to use those materials to solve a problem. So if you're watching this recording, we ask you to just pause the video for now, go get those number pieces ready to go. Okay, now that everyone's had a chance to do that, I'm going to ask you to try this problem with your base 10 materials, however you've chosen to use them. I would like you to please represent 12 multiplied by 3 in as many ways as you can. And while you're doing this, I want you to think about your students and anticipate all the models they might use to show you what 12 multiplied by 3 means. So if you're watching this video again, pause it here. Anticipate student thinking. If you started with a model like this, which a lot of students do, you will see here we've got 12, and we've used 2 tens to say times 3. This is where a lot of students begin. It might be where you began as well, but we're actually looking for you to model what multiplication means to you. So with that hint in mind, go back to your models and see if you can add any more. And if you've never done this before, you might be feeling some productive struggle right now. That's what we call it when you're feeling that frustration, you're trying to figure out a problem, you're thinking about it, you don't know how to do it. That's actually when your brain grows the most. And when our students are feeling frustrated because we've given them a challenge that is within their reach, if we can notice and name that productive struggle for them, it actually empowers them to persevere through it and to stick with the challenge until they have worked through it. So now that you've had a chance to model some different models of multiplication for yourself, I want to show you a sequence of student thinking. All of these images come from work that Prisha and I have done with students and teachers, and we've put it in a deliberate sequence to show how different models of multiplication are related to each other and to help you know what you're looking for when you see these models come from your students. So when we asked them to do this, a lot of students did this. They made 12 groups of 3. And in this groups of 3, when they lay out these materials, not only are you looking for those groups, but you're looking to see how students counted them. Did they skip count 3, 6, 9, 12, or did they count them as they pulled them out? That's going to give you information about what they understand about multiplication. And if students also show that 12 groups of 3 is equivalent to 3 groups of 12, this is a really important property of multiplication. It's called the commutative property. And knowing that it doesn't matter what order those numbers are in, knowing that 12 multiplied by 3 is equivalent to 3 multiplied by 12, we just divided the number of multiplication facts a student needs to understand in half. Because 3 times 4 is 4 times 3. 5 times 6 is equal to 6 times 5. So this is a really important thing to notice in the student work and to name for them and to get really excited about. And groups of is a really important model for multiplication. And if you notice that some of your students were doing this and some of them weren't, you want to stay here and model lots of different multiplications that have numbers that are really easy to model in different groups of. But when your students are ready to move on, the groups of model has limitations. And so if you see that a student has built a model like this, you might encourage them to turn that into a rectangle, because we're actually looking for the next model, which is called an array, where we have those 3 groups of 12 or 12 groups of 3 organized into rows and columns. And if one student often will do this in a class, but if not, we can just nudge them towards it by saying, could you organize your model into a rectangle? And once we have that, we might ask them, where do you see 12 groups of 3 and where do you see 3 groups of 12? So I would like you to pause now and look at that model, that array model, and see if you can connect it back to the 12 groups of 3 and 3 groups of 12. And if you can write in the chat how you would help your students see those groups.
Nothing yet.
That's okay. We value quiet think time and wait time around here.
Christy says it encourages students to look for rows of 12 and columns of 3.
Okay, so I think what you're saying, Christy, is that here we see a column of 3, and we could help students count over and say there's one column of 3, here's a second one, a third one, a fourth one, all the way up to 12 columns of 3. And we could also help them see there's one row of 12. We can see 1, 2, 3 of those. So this array model links back to the groups of model, but we're going to see in a moment how it links forward to a strategy that can take us further in our math thinking.
Can I just add, there's some other comments?
Absolutely.
Lynn also added, it's almost like length and width. So I'm thinking that you're connecting this to area.
Okay, nice.
Big connection for our students. And then Jessica said that looking for groups to add up. So here you can visually see a group of 10 when you're adding it up.
Oh, very cool. So if we can see we've got 3 10s and 6 1s down here. And in fact, if we ask students, now that you've modeled it this way, what is the answer to 3 multiplied by 12 or 12 multiplied by 3? A lot of them will say, well, I see 3 10s and I see 6 1s. And if we record that thinking for them, we're actually going to pull out all the ideas that all the participants just shared in the chat. Let's go forward again. We can see the area model, because multiplication can be represented as the area of a rectangle. So we see the 3 as this width of 3. We see the length of 12. We've shown how a student might decompose that into 2 plus 10. And we can see the 3 10s as 30 here. We can see the 6 1s over here. And so we know that 12 multiplied by 3 is 36, because 30 plus 6 is 36. Does anyone have any questions about the area model that's on the screen right now?
No.
Okay, so when we are starting to build from groups of to arrays to the area model, we want to stay with concrete materials for a long time. We want students to be building. If we have ELL learners or learners with other exceptionalities, we know that moving those materials around can help them not only learn the multiplication facts, but actually communicate their thinking to us. And so they are a great tool in many different ways, and we don't want to leave the concrete yet. Students need to get really comfortable building lots of area models with lots of multiplication facts that are accessible to them. Once they start to say, okay, I got this, and we notice that they're very fluent building these models, they might start to record their thinking in a drawing. And I want you to keep your eyes on the screen right now, because this is what students might start to draw. And if they have built a lot of models with their materials, this model is going to make a lot of sense to them. And so we still have an area model, but some people will call this the box model, because we've moved from concrete materials to a visual model now. And this makes a lot of sense to students if they can connect it back to those concrete materials. So I want you, yeah, for sure.
Jackie, just from experience I've had back in the classroom, how quickly I rushed to the area model. And I did not give enough time with the concrete materials, because I could see it. I'm like, oh yeah, we can do this. And it just, my students were lost, because we didn't spend enough time with the concrete. We went right into this area model, this visual model of this, and they weren't able to make the connection. So I just want to reiterate like how important it is to stay in that concrete model until they really have a strong understanding. Sorry.
No, I really appreciate that. And I noticed the same thing in secondary when we learned about the box method. We went straight to that. And it was only when we actually went backwards and took out the base 10 materials and the algebra tiles that students really deeply understood what we were trying to get at there.
And so now, adding to our comments that, yeah, students need a lot of practice in this concrete, especially in junior grades.
Absolutely. I would say that that isn't limited to junior grades, though. I think whenever we start with larger numbers, or when we move from this to algebra, or when we move from this to fractions, then we need to go back to the concrete materials, no matter what the grade.
Yep, for sure.
So keep this in mind, folks. And now you're going to try to represent 12 multiplied by 23 with the base 10 materials that you have open in another tab. So if you're watching the video, please pause it and anticipate all the different models that students might use here. So you've had some time to try this. Again, I'm going to take you through a sequence of student solutions, and I'm going to ask you to keep your own models in mind and see where you see them in this sequence. So some students, when we give this problem to them, they're still most comfortable with the groups of model. So we will see some either 12 groups of 23, 23 groups of 12. We more often see 12 groups of 23 because that's fewer groups. But if we want to nudge students, if we think they're ready to move from groups of to this array and area model, what we might do in the classroom is limit the amount of materials we give them so they can't actually build 12 groups of 23. When we do this online, it's a little harder because they have unlimited materials. So we might have to ask them outright, do you think you can challenge yourself and build an area model with this? And students will definitely experience that productive struggle here. And we have to tell them that's okay. That's where you're learning. Persevere, you're going to get there. And after enough wait time and quiet think time, we will see this. And I want you to think about where you see the 12, where you see the 23, And where do you see the answer to that multiplication problem of 12 multiplied by 23? And if you can put any of those thoughts into the chat, that would be really great. Are we seeing anything there, Prisha?
Not yet. Just, I think give some time.
Absolutely. I just got excited, sorry.
It is so exciting, this math. I get excited about it. Christy says she sees the dimensions 23 by 12 in the rectangle.
Okay, so a 12 here as either the width or length, however you define it, and 23 on the other dimension.
Yeah, Alana's 23 across the top and 12 going down. Yeah.
Okay. Does anyone know where the answer to 12 times 23 is?
Yeah, so Jessica, sorry, just said I see groups first, 2 groups of 100 and then tens and ones.
Oh, so 100, 200, 210, 20, 30, 40, 50, 60, 70, 270, 1, 2, 3, 4, 5, 6, 276. Is that what you were saying, Jessica?
Yeah, 276.
So that's where we see the area representing that multiplication fact. And I'm going to take that same thing and do a little bit of decomposition for you, because students will see this. They will see that we've taken that 23 and we've decomposed it into 20 plus 3. We've taken this 12, we've decomposed it into 10 and 2. And that's where we get that 10 multiplied by 20 gives us 200. 2 multiplied by 20 gives us 40. 2 multiplied by 3 gives us 6. And 10 multiplied by 3 gives us 30. So I want you to have a look at that. These strategies are really helpful for students. They're making a lot of connections here. We've already talked about the connections to measurement. Decomposing number and shape are really important. And I want you to just keep your eye on this model. And we're going to go one more step further. Does anyone have any questions before we do that? Do you see any questions there, Prisha?
No, not yet. And I'm wondering if someone did have a question, if they want to put just on their mic, just say it out loud if you have a question.
For sure.
Easier. But no questions so far.
Okay, so we're going to make even more connections now, because we know the more connections students make between different math ideas, the more deeply they understand the math. So have a look at this. And I would like you to consider this question: what connections do you see? And if you have a connection, either turn on your mic and share it with us or write it in the chat, please. Do we have any comments in the chat?
This one come up, decomposing into place value.
Oh, right. Nice. So we can see that decomposition of number, the 23, into tens and ones. We can also see that the area has been decomposed into hundreds, tens, and ones, as Jessica noticed before.
And there's 4 sections in the model.
All right. So we have 1, 2, 3, 4 sections here, 1, 2, 3, 4 sections here. So we've decomposed that rectangle into composite shapes.
Oh, great start to algebra.
Nice. There's going to be a connection further ahead to algebra, absolutely. And in fact, we use models like this all the way up to grade 11. And I want you to just quietly think how you think this might support the students that you tend to work with. I know we have a lot of EAs in our session and some ECEs. And I want you to think about the students that you know and how working with concrete materials before we move to that visual and this type of model might support those students.
So Jessica says being able to see the numbers. I think actually that really brings out the magnitude of the number too, how big it is. Elena says understand the why.
Yes. The why behind the multiplication, that's awesome.
Yeah.
Okay, so speaking of the why, going one step further. So we know that we always start in the concrete, then we move to visual models when students are ready to draw their thinking. And then eventually we will go to an algebraic or a symbolic or an algorithm. So now we've moved from this visual model to an algorithm. But as we have these two side by side, I want you to tell us what connections you see between the two models, please.
Shown with the concrete before the algorithm.
Nice.
Does. Yeah. Very helpful.
What was that last one, Prisha? Sorry. Yeah. So I'm thinking about the comment earlier about the why in the algorithm. And I think when we talk about this algorithm, sometimes we say, well, do 2 times 3. So there's our 6. Then we do 2 times 2 with a placeholder of a 0. What about saying we're taking 2 multiplied by 20? And then we have 10 multiplied by 3 and 10 multiplied by 20. Understanding what's actually happening in that algorithm is easier when students can see this visual model.
One thing that it just becomes so clear for students that you're not just doing 1 times 2.
Absolutely. Okay, so I think there's one other thing we need to say here is that this approach, rather than going straight to the algorithm, might be uncomfortable for us as adults. I know when I first learned all of these other strategies that I was a little bit uncomfortable. And now that I understand how much it helps students, my discomfort in having to learn this new strategy and these new models was really helpful. So it might be uncomfortable for us, but it is actually better for our students.
And Jackie, can I just add one thing?
For sure.
Sometimes I hear students kind of come up with their own little way of memorizing the algorithm. Like there's a turtle, some sort of turtle one that I've seen or whatever. And that's built on a memorization of something they really don't understand. So when we go back to that concrete and area model, all of a sudden when we're presenting them with the algorithm, it's not about a memorization now, it's about a true understanding. And so if you are working with a student that has been struggling this much and has somehow memorized the algorithm, it doesn't really mean they have an understanding of what's actually happening with multiplication. So they might have a way to understand it, but we need to go back to them to that concrete area model just to solidify what it actually means.
Right, because if they understand it, they can extend it forward into other math concepts and they can make more connections. If they've just memorized it, they're going to have to memorize a whole new thing for each new topic.
Yeah.
So the other thing we want to do when we're looking at multiplication is go back and forth between multiplication and division. And the next problem you might try with students is starting with the area and going back to the length and the width. But we don't have time to do that today. I just want to put that out there as an idea. And I just want to connect to why we do this. Marion Small is a well-respected Canadian educator and a leader in math education. And she tells us that there are actually lots of different algorithms for all of the operations. So that multiplication algorithm we're comfortable with is just one of those. We just happen to be really comfortable with it as adults because of how we learned. And it's really important that any of those procedures are always taught with meaning. And the sequence we've taken you through is one way to do that. So what we want to do now is once students have gone through a sequence of understanding multiplication, how do we let them practice this in a really purposeful and meaningful way? And we want to share with you a few different games that are a really great way for students to practice this. So focusing on the area model, the first game is called How Close to 100. This game comes from Joe Bowler. And you can see right here is a paper version of this game. In fact, let me keep that big for one moment. So that paper version of the game, you can print off a game card, or you can actually just use grid paper or any kind of graph paper, and you just need a couple of dice and a marker. We have created a digital version, which Prisha and I are going to play right now to show you. And in fact, you can see that we have already begun our game. So we're just going to continue our game. So I'm going to roll the dice here with my online dice roller. This little link here takes me to little visual dice roller. So I've got a 6-sided dice that landed on 2. I need a second 6-sided dice. Got 2 multiplied by 3. So if I go back in here, oh, that's interesting. I had a 3 times 2, so now I'm going to do 2 times 3. So I'm going to think about that as either 2 groups of 3 or a 2 by 3 array. So I think I'm going to go 1 group of 3, another group of 3. So now I have a 2 by 3 array, which I can see is 2, 4, 6. So I'm going to write that multiplication fact down here on the bottom.
And how awesome is that? Now I can actually name that, Jackie. I think you did the commutative property.
Oh, awesome. Thanks. So now it's your turn, Prisha.
Okay, I'm rolling dice. I got a 2 and I've got a 6. So I'm going to grab the 6. Oops. Uh-oh. And maybe down here.
So the goal of this game is for Prisha and I to work cooperatively to fill this game board. And so you can see Prisha's doing some strategizing to figure out the best place to put that. It's a little like Tetris. You got to use your spatial reasoning as well as your understanding of area and multiplication. And so you could play this with a student. We just happen to be in the same slide deck, and you could do the same thing from your slide deck, make a copy of this slide and share it with students, and they could play it with someone in their home, with each other, or in a small group in a Google Meet, just like this. Okay. So I'm going to leave our game, Prisha. Good job.
Thanks. You too.
And if you lose a little bit of time in your life because of this next game, we apologize. But if you go to a site called Mathagon and find their game called Factress, there's a link there. It gives you the factor of 20, or the product of 21. And then you can click on it many times to get all the different area models that you might get. So here's 3 by 7. It would click through and give you 7 by 3. If you had a product that had more factors, you get more options, and you just keep clicking until you get the block you like, and it settles down in. And again, you're trying to fill up that space just like in a traditional Tetris game. So it's a really great way to gamify that learning of area model of multiplication. And you really want to stay in the area model games for a long time until students are comfortable with that. Once they have built an understanding of multiplication, then we can move on to other games. So here we are looking at the area model, but we are looking at bigger numbers now. And so MashUp Math has these great area model puzzles where you have to think about what would the width and the length of this rectangle be decomposed into tens and ones, and what would those partial products or those smaller areas be to make up the full area of that rectangle. So these are really great puzzles. You can just print them off in the classroom, but here what we've done is we've made an interactive version again, and you can just slide these numbers over based on what you think those might be, which is a really great for risk taking, because if you've got it wrong, you just move that number somewhere else. The next game we have is when students are ready to move away from that area model and to just work with their multiplication facts. It's called Multiplication Pathway, and I think we'll just go ahead and play that game.
Sure.
So right now we've got arrows on 3 and 4, and so the last piece that was placed was 12, because 3 multiplied by 4 is 12. And so the blue player, which I think was me, when we started playing this, I'm trying to make a pathway. It doesn't have to be straight. So I could, as long as I could get 18, 40, 12, and 49. I could get 18, 32, 35, 15, and 48. I just want to get a pathway across the card in some way. And so the way we do that is I had 3 and 4. So it's Prisha's turn now. She has to move one of those arrows, but she has to leave one of them the same. And she's red. So she has to either make her own pathway or try to block mine.
And one question that was asked last time I was playing this was, can I go up and down, or can I go sideways as well? You can go sideways, up and down is totally up to you. Probably easier to go up and down because it's a shorter path. So I'm going to say, nothing's really helping here. I'm going to do 4 times 8, because I think I'm going to try to block Jackie.
Ouch.
I know, sorry, Jackie.
You don't sound sorry. Okay, well, that actually helps me because I want to do 4 times 7.
Oh, you could do 8 times
7. You can do 4 times 7, because I know 2 times 7 is 14. I'm going to double check that that's true. So then double that again, that's 28. Oh, yeah.
Oh, but you know what I'm going to do?
Oh, I know exactly what you're going to do. Because I didn't know that you could use the arrows in the same number until the last time we played this. And now I can't get to that 25, Prisha.
Sorry.
So you can see that there's a lot of strategy here. There's a lot of anticipation. So I'm looking at all the numbers that I want to go to, and I'm thinking about what their factors are. So there's a lot of working with the numbers. And once students are ready for this, it's a really great game. Okay, so we don't need to show you where the K-12 math resource is, because that's where you have found this recording. But I do want to highlight a few resources within the K-12 math resource that are going to support you and your students as you build number fluency with multiplication facts. So I'm going to get out of my presentation, and I am going to go to the K-12 math resource, which looks like this. And the buttons across the top are how you navigate the content of our site. So you're going to go to elementary. And that's where you're going to find a lot of these resources. You can find fluency games and activities as the first tab underneath elementary. There are some math games for remote learning here, but all of the games that we have are listed by category. So the multiplication ones are here. When you click on that, all of the different strategies students will use for multiplication and division are here. And if you really wanted to focus on arrays, you would click on that link, and you would get to some of the games that we shared with you, a reminder of what an array is visually, which is really helpful, and some other games that you might play. And you can go back to that and find for different multiplication strategies, what are some games that you might play. And if those games require game boards or anything like that, if you scroll down further, we can find all of the game cards in there. And if there's anything else you're looking at in other topics, or looking for rather, all you do is you click on the strand, and you can find all sorts of resources that can help you. Once you go into one, you'll notice that there are a mixture of Google Docs, Google Slides, videos, and various things that you can use in remote learning as well as in your classroom when we're back to some semblance of normal. Is there anything else we should highlight while we're here, Prisha?
Maybe, did you go down to the tools?
Excellent. So if we go into web links, we have some ideas and tools for remote learning. So you can find some information and some videos. The videos are all very short. In the toolbox, you can find some online manipulatives and other tools that are really helpful, and some videos introducing how to use those tools. And you can find all sorts of other things, purposeful practice. You can find all sorts of math games for online and other ways to do purposeful practice for multiplication and other topics. We can see here under multiplication, there's some really great online ways to practice the area model in particular.
Perfect. Thanks,
okay.
Stephanie.
Thank you, Prisha. And thanks everybody for being here today. And reach out if you have any questions.
Thanks. Bye.
Bye-bye.